In this first example of solving a separable differential equation, we are going to find the general solution to the differential equation dy dx equals x times the quantity 1 plus y. In accordance with how we solve separable differential equations, we need to separate the x's from the y's to the opposite sides of the equation. If we first multiply both sides by dx, we would have dy equals x times the quantity 1 plus y times dx. But now we need to divide over the 1 plus y quantity so that the y's are on the left side of the equation and the x's are on the right. We now take the antiderivative of both sides of the equation, and now we find the antiderivative as we typically would do. On the left side, the antiderivative of 1 over 1 plus y is the natural log of the absolute value 1 plus y. You could think of doing this as a u substitution problem, but notice how the derivative of 1 plus y would simply have been 1 dy, so there really is no need to do u substitution. On the right side, we get 1/2 x squared plus c. That's pretty much the end of the calculus for the problem. Here on out, it's an algebra problem in which we need to rewrite this natural log equation in terms of exponential equation. If we have the natural log of the quantity 1 plus y equaling this right side of the equal sign, remember that by definition of a natural log, that means that e raised to the 1/2 x squared plus c would give us 1 plus y. Now, we can drop the absolute value bars because if you notice, because of this x squared quantity, it's always going to be positive anyway, so we can eliminate the absolute value bars because of that. Here again, we apply a little bit of algebra. If you take a look at the left side of the equal sign, notice how in the exponent you had this added quantity. If we were to use the laws of exponents, sort of going backwards, we could rewrite this left side of the equal sign as e to the 1/2 x squared times e to the c, because notice you have two quantities multiplied together with the same base, therefore the exponents would be added together. E to the c, notice, is simply a numerical quantity. E we know to be the number 2.718281828, so on and so forth. C is representative of a constant number, so this quantity e to the c, we're going to represent that as a different letter. I often use the letter K. You could really use anything. Some people use capital N. You could even use another C if you wanted to. It just represents a different C. I'm going to use K. So rewriting this equation then, substituting K in place of e to the c, I would get K times e raised to the 1/2 x squared equals 1 plus y. I now easily can solve for y by subtracting 1 from both sides. And I now have my general solution to the differential equation.